what we're doing here is just looking at how you actually tell if a precipitate's going to form, and also just some really short things on oxidation reduction reactions. So you've already talked about net ionic reactions and like what net ionic reactions are, but we haven't really talked about like why they form or how they form. So when you mix two ionic compounds, sometimes you get an insoluble salt, and remember we call that a precipitate, but other times you can put them together and you get no precipitate. Sometimes you get a liquid, sometimes you get a gas, but we're going to focus on the precipitates today. So you can actually predict if you're going to get a precipitate using some general rules here. So you can see here, there's just rules. If you're soluble, that means that you would not be a precipitate. And if you were, if it likes me, if you were insoluble, that means there would be a precipitate. So just so you have that, if it likes me. Maybe not. There we go. So if you're soluble, no precipitate. And obviously if you're insoluble, there would be a precipitate. So there's just some rules, like alkali metals and ammonium are soluble. If you're a nitrate or a chlorate, you're soluble. Some of them have exceptions. And then carbonates, phosphates, chromates, sulfates, and hydroxides are insoluble unless they're with an alkali metal or ammonium. So this is not in your note packet, but just so you have some practice with it, we're just going to go through and say, are these soluble or not, like basically reading the chart. So the first thing here is potassium carbonate. So this is a carbonate, and if you read the chart, carbonates most are insoluble. However, carbonates with potassium, and potassium is an alkali metal, and alkali metals are always soluble. So this one right here would be soluble. Second one we have is silver chloride, and we have to find our chlorides. It says chloride salts are soluble, so they would not be a precipitate, except when they're with silver, lead, or mercury. So since it's with silver, that means instead of being soluble, it's going to be insoluble. Next one is calcium nitrate. So you find nitrates, it says nitrates and chlorate salts, they're always soluble. So this guy is definitely soluble. Next one is lead sulfate. So again, you have to find it on the chart. So it says sulfate here, and it says sulfates are soluble except when they're with lead, silver, mercury, barium, strontium, calcium. So they should be soluble, but because he's with lead, that means he is insoluble. And last but not least, we have copper chloride. So it says chloride salts are soluble except for when they're with silver, lead, or mercury. We're not with that, so this is soluble. So if you're looking at these, the only two precipitates we would have a precipitate with silver chloride, and we would have a precipitate with lead sulfate. All right, so what you can do here is you can actually predict the products, do your net ionic reaction, and you can do your net ionic reaction because you can identify which one of these would be your precipitate. So you do your double replacement, and we get BaSO4, and we would get HCl. And then to balance, we would need 2 of those. So you look back at your solubility chart on the last slide, and you say, okay, we had hydrogen chloride, so we can look here. Chlorides are soluble except for with silver, lead, and mercury. We don't have that, so that's soluble. So this would be aqueous. It likes me. And then we go back and look at our sulfate, our barium sulfate. So sulfates are soluble except when they're with lead, silver, mercury, barium, strontium, or calcium. So it's with barium, so then that means this right here, if it likes me, is our solid, is our precipitate. So you can use a solubility chart to figure out which one of these would be your solid. So then you would write everything out like we've done with the net ionic reactions. You would ionize it, all that kind of good jazz. And what you should end up with as your net ionic is you would have, I don't know why it's not typing, let's see. Well, that's not good. Here, we'll do it there. You would have a barium ion plus a sulfate ion and it would be making BaSO4 as a solid. Your spectator ions, still not working. Let's try that. Our spectator ions would be our hydrogen ion and our chloride ion. So try this one down here, and then when you come back, I'll just have it right on there with it. I'll just type it in quick. So see if you can figure out which one of these would be the precipitate, and then go from there. So let me just do this. So you should get that the aluminum hydroxide would be your solid, and then if you would write your net ionic equation, what you would have is you would have the aluminum ion in aqueous form. Ooh, I didn't balance this, I apologize. So we need a 2 here, we need a 2 here, and what am I doing wrong? Oh wait, that's 6. 6 and 3. Sorry. So you would have this. You would have 2 aluminum ions plus 6 hydroxide ions. And you would be forming 2 of the aluminum hydroxide solids. And again, your spectators would be sulfate and ammonium. So hopefully this helps to kind of say, like, how do we know these things occur instead of just me saying, oh, that's a solid or that's a liquid.